Ladies and gentlemen, over the last few weeks, I have been taking a break from my mental health to bring you TikTok videos on how to use Terraform. And I decided that I would take all of the videos that I created over on TikTok, compile them into one large video for your viewing pleasure over here on YouTube. And we're using the GitHub provider to learn Terraform in these videos because I feel like that is the least barrier to entry. Nobody really wants to create an AWS account and upload their credit card information for a free tier account, right? So that's why I chose to use the GitHub provider. So like, subscribe, enjoy, hope it helps you. If it doesn't, it's free stuff. To get started installing Terraform, go to Google and simply Google install Terraform. Now, you're going to end up at one of two pages. Most likely, you're going to end up at this first one, in which it brings you to developer.hashicorp.com/terraform/tutorials/AWS get started install CLI. I suggest you start at this page. You may also end up at this page, which brings you to the actual page to download the Terraform binaries. The reason I suggest you start at this page is because it has some handy information. You'll see this drop down that says install Terraform, and you have manual, homebrew on OS X, Chocolatey on Windows and Linux. I'm doing this on Windows, so I can either choose Chocolatey or manual. I'm going to choose manual because this is most likely the way you'll install it on a lot of different things. So we'll do manual, and then it says retrieve the Terraform binary by downloading a pre-compiled binary or compiling from source. Here's precompiled binary, here's compiled from source. We're going to do the precompiled binary. So then I'm going to click appropriate package, and this will bring me to that page earlier that I showed you with all the different binaries. I'll pick my operating system, Mac, Windows, Linux, etc. I'm doing Windows, and most likely you're on AMD 64. If you're not on AMD 64, you probably know that you're not on AMD 64, so go ahead and choose 386. I'll click download, and that should download the Terraform binary zip file. Go ahead and open up that zip file. Once you open up this zip file, we have to take this Terraform application and put it in a folder on our computer somewhere. So I'll open up my F drive, and I'll create a new folder here. And you can put it anywhere you want on your computer, and I'll just name this Terraform. And then I will take this, and I will put it into that F drive Terraform folder. So now this is the location of my Terraform executable. Once we've downloaded Terraform, opened the zip file, and extracted that file to somewhere on our computer, the next and final step is to actually add the Terraform binary and make it available in our system path. So if you follow the instructions here for Mac or Linux, they're fairly simple, but for Windows it gets a little more complicated. There's a Stack Overflow article you can click to learn how to do this, but I'm going to show you an easier way. In Windows, go ahead and go to your search bar and begin searching environment variables. And this will bring up the edit system environment variables. And then you can click that and you'll get this window, and you can click environment variables. And that'll bring up this window, and one of these environment variables is called path. You can go ahead and click edit. And you're going to want to add the place that you put the Terraform file as a new environment variable by clicking new and then typing the location. So mine was f:\Terraform, and that is the folder that my Terraform application sits in. Now I'm not going to add this, and I'm actually going to delete it because you can see I did it earlier. It's right here. Optionally, you could add the Terraform binary to one of these existing paths, and this would still work. Click OK, and click OK. Now with Terraform installed and our path set, we can open a PowerShell terminal. And from anywhere on our computer, for instance, I am in the C drive user Joshua, we should now be able to run Terraform version. And it should find our Terraform executable that we just downloaded and execute it. Before we begin, go ahead and go to github.com. And if you do not have a GitHub account, go ahead and sign up, create one. It's free. You don't have to pay anything. Once you've got Terraform installed, it's time to pick a provider. And a provider is a plugin within Terraform that talks to an API. Want to deploy to AWS? There's a provider for that. Want to deploy to Azure? There's a provider for that. Want to deploy to Kubernetes? There's a provider for that. Want to deploy to Cloudflare? There's a provider for that. Providers are hosted at the Terraform registry at registry.terraform.io. For each provider that you're interested in, if you click on it and look at the documentation, there's usually some information about how to authenticate with that provider to the API. When looking at providers, you'll also see something over here called a tier of provider. For instance, AWS is an official provider. There are three main tiers of providers, and we have official, which are owned and maintained by Hashicorp, partner, which are providers owned and maintained by a technology company, and the community, which are providers published and maintained by individual contributors and the ecosystem. For this video, we're going to look for the integrations GitHub Terraform provider. And this provider is going to let us manage our GitHub organization as code. We're going to be able to create GitHub repositories as code. If we look at the documentation for this provider, they give us some information, some example code on how to use it, some notes, and how to authenticate to our GitHub account in order to start creating a repository and other resources with this provider. So let's stop there, and I've opened up Visual Studio Code on my computer. I highly suggest you follow along with me and download Visual Studio Code. Simply Google Visual Studio Code download. So in Visual Studio Code, in the top left, the Explorer, I'm going to open a folder. And this will open my File Explorer on Windows, and I'm going to choose a folder that I want to put my Terraform code in and work from that folder. So I'll stay here in my home directory. I'll create a folder and I'll call this Terraform_code. And I'll select that folder. And now I am working from the Terraform code folder. I'll go ahead and I'll create a new file, and I'm going to call this main.tf. I'm also going to come up here. I'm going to go to terminal, and I'm going to say new terminal. And so what this does is it opens a terminal in VS Code below. And what having this terminal open allows me to do is now I can run Terraform commands from the same workspace where I'm working on my code. So I can create files, add Terraform code to them, and then run the Terraform code from here. Now this area, this folder or directory that we're in, is what's known as our Terraform working directory. When we run commands such as Terraform init or Terraform apply or Terraform apply, this is the directory where Terraform will look for every file ending in the .tf extension, read them, and then begin to execute upon those files. We usually start with a main.tf as an entry point into our Terraform code. However, as you build more and more Terraform code and it becomes more and more complex, it is common practice to start separating your files based on use case or resource, such as s3.tf or rds.tf, etc. We're going to start with a main.tf file. So now that we have created our first Terraform file, let's go ahead and grab that provider example block from the documentation for the GitHub provider. Go ahead and copy the code from Terraform all the way down to provider GitHub. And then back in our main.tf file, go ahead and paste that. Starting with line 1, the Terraform block is a special block within Terraform where we can configure some behaviors for how Terraform operates itself. Here on line 2, we are defining a configuration required providers block nested within the Terraform block that says these are all the providers that we require when we run the Terraform code. And here's where we source these from: the public Hashicorp Registry, integrations, GitHub, and here's the version that we would like. And within versions, we can specify different operators such as greater than, less than, equal to really lock down those versions. Or we can say, in this case, this is what's known as a pessimistic constraint operator that says allow only the rightmost version number to increment. So we cannot go above 5.0, but we can do 5.1, 5.2, etc. And then here is our actual provider block. So for every provider we use, we need to include a provider block. And within this provider block is where we will define the configuration settings for our provider, such as how to authenticate to our API. In our case, how to authenticate to GitHub. The provider documentation tells us all of the valid options or configurations we can give to the provider block. We'll be using the token one in order to provide the provider block with our GitHub token so we can authenticate to GitHub with Terraform. In your GitHub account, select your user profile picture in the top right, and then go to Settings. Under Settings, all the way at the bottom, go to Developer Settings. In here, we'll click Personal Access Tokens, Token Classic, and then we'll generate new token, and we'll generate new token classic. We'll give this token a name, like Terraform, and we'll choose how long this token is valid for. I'll choose 7 days. And then we need to provide some permissions to this token. What is this token allowed to do? I want it to be able to create repositories and have control over my repositories. I want it to be able to also delete repositories when I do Terraform destroys. And that's all we need for now, and we'll hit generate token. You'll get your token here. Go ahead and click this to copy it, or just copy it. And make sure you protect this. Don't share it to anybody, and never push it to GitHub itself. We'll take our GitHub token, we'll go into the provider GitHub block, and we'll specify token equals quotation marks, and then we'll paste our token. Another and more secure way to provide this token to our provider is to use environment variables. So we'll remove the token line from our provider configuration altogether. Windows, I can set the environment variable $env: GitHub _ token equals quotation mark token close quotation marks. And that will set an environment variable. If you are on Mac or Linux, you can do export and then GitHub token equals and then the token. And then to verify that that token is set as an environment variable on Windows, I can do get-child item env: and that will display all the environment variables set, and I can see that GitHub token is set. And if you're on Mac or Linux, you can do the print env command, and that will print all of the environment variables. And now we've successfully configured our GitHub provider, so Terraform can authenticate to our GitHub account and begin creating GitHub repositories with Terraform, and we'll do that in the next video. In the last video, we chose our provider, the GitHub provider, so we can create repositories in our GitHub account with Terraform, and then we configured that provider to authenticate using environment variables. In order to start creating things with Terraform, we need to define what's called a resource block. And in Terraform, resources are anything that you want to create as infrastructure as code. A server would be a resource, an IP address would be a resource, a security group rule would be a resource, and in our case, a GitHub repository is our resource. For every provider, if you go to the documentation and you browse, there is a resources section, and these are all of the available resources that we can define with our Terraform code. We're interested in the GitHub _ repository resource, and if we click on that, we get some example code, but we can also see all of the arguments we can use within this resource block. Not all of them are required, and these are specified by the optional attribute, and then some are specified by required. For our example, we'll go ahead and copy the first example usage under the GitHub repository resource, and we'll paste that into our code. And for now, let's go ahead and remove this template attribute. Every resource that we define in our code must have its given resource type, which is GitHub _ repository, and that cannot change, and it must have its given resource name, and that can change. The resource type and name together serve as an identifier for the given resource and must be unique for each resource within your Terraform code. By unique, I mean if I wanted to create 2 repositories, I could not have the same resource named example and example. I would have to have something like example 1 and example 2. So I'll change my resource name to something meaningful to me, and I'll call it repo. And then every one of these options within the resource block are known as attributes. So this will be the name of the repository that I want to create. So I'll call this my Terraform repo. And then we can give this repository a description. And then we can choose if we want to make this repository private or public. Now that we've defined our resource, we're done writing our Terraform code. And once you're done writing your Terraform code, it's time to start running Terraform to actually create your resources. So making sure that my GitHub token is still valid as an environment variable, I'm going to go ahead and run Terraform init. And what Terraform init does is this will look at all the providers within your code, and it will download them to your local machine. Once the Terraform init is done, you'll see some additional directories and files be created within your working directory. The .terraform directory will contain the providers that were downloaded, and additionally, if you're using Terraform Modules, this is where those will be downloaded to as well. You'll also get a terraform.lock.hcl file, and this is just a dependency lock file for caching. After terraform init, the next command we would want to run is terraform plan. And terraform plan will look at your code and it will tell you what exactly Terraform is going to do. In our case, we want to create, and it will tell us what Terraform wants to create, one repo, and all the attributes of that repository. And some of these will not be known until after apply, and those say known after apply. And we can see we have 1 to add, 0 to change, and 0 to destroy. Now, Terraform plan will not actually create anything, and in order to do that, we have to run a Terraform apply. And a Terraform apply will run a plan, and then it will prompt us, would you like to create the resources or do whatever the plan says we're going to do? In our case, we have to enter yes because we would like to create our repository, and then it says creating, and then we should have a repository created after apply complete. So now if I look at my GitHub account, I do indeed have a repository called my Terraform repo. And this matches the name of the repository that was created by Terraform. Now we've successfully created our first resource in Terraform, and in the next video, we'll go over the state file that got created when we ran a Terraform apply. In the last video, we created our first Terraform resource using the GitHub provider, and we created a GitHub repository in our GitHub account. Now, when we run a Terraform apply and we actually create something, a file called terraform.tf_state is created. And the terraform.tf_state file is a JSON file, and it's a representation of how Terraform believes our infrastructure is configured after the Terraform apply is complete. If we look through this state file, there's a resources section, and we can see that we have a GitHub repository resource and all the information about how that repository is configured. Now, anytime we do a Terraform plan or Terraform apply, something called a state refresh happens, in which Terraform goes and compares the existing infrastructure to the state file, and then it determines, do we need to create, change, or destroy anything? Here you can see I ran a Terraform plan, and there are no changes because my GitHub repository matches what's in the state file. If you followed along with the last video, we set the repository that we created to a visibility of public. I went ahead and modified the visibility manually myself outside of Terraform in GitHub in order to demonstrate that now when I run a Terraform plan, the state file is refreshed and Terraform sees that the visibility of the repository no longer matches what you have configured in the Terraform code. Therefore, Terraform wants to update the repository to match the Terraform code. So I'll run a Terraform apply, and this will put my GitHub repository back to public visibility. Now there's an additional Terraform command that you have not seen yet, and that is the Terraform destroy command. And Terraform destroy will actually destroy, right? It says that we are going to do the destroy operation, and we are going to have one to destroy the infrastructure that you've defined. And now that it's been destroyed, my GitHub repo no longer exists because I have destroyed it. And you can see that the state file has been refreshed and there are no resources within it because we've destroyed all of them. And additionally, there's something called a backend block that we can configure within our Terraform block that tells Terraform to put our state in a remote location or a different backend than the default local working directory. And we can specify different backends such as remote, S3, Azure, GCS, and so on. And we won't go over that in this video because we don't have any AWS resources configured yet, but we will go over it in a future video. In this video, we're going to talk about using multiple Terraform resources at once and then referencing other Terraform resources for our attributes values. In this video, we're going to create a GitHub repository file resource with Terraform, which will create a file inside of our Git repository after the repository is created. So over on the GitHub provider documentation, you can search through the documentation, the different resources until you find GitHub repository file, and then go ahead and copy the resource GitHub repository file from the example usage. Back in our main.tf file, we'll paste that code. So the GitHub repository file resource, we have to define a repository that we would like to put it in. So we could hard code a name here. Like I could just take my Terraform repo and pop it in here. But as you scale Terraform and you begin to use it more, normally you're going to create resources that you won't know values for until they're already created. And that means we have to then reference that value somehow. And this is how we do that. So we can say for a resource type, GitHub repository with the name, right? In our case, our GitHub repository resource is named repo. Go ahead and access that resource and use the name attribute. So this name attribute for the value of this resources attribute. So here we're saying, go to the GitHub repository resource named repo, look at the name attribute, and use that for the GitHub repository file repository attribute value. We're going to remove branch here because we are creating an empty repository with no main branch at this time. File, this will be the name of the file to be created inside of the Git repository. I've named it test. Content will actually be the contents of the file. So when we open the file, we should see these contents. I've just typed test contents, and we can leave everything else the same. So now we can run a Terraform apply, and we should have two resources to create because we deleted the repository earlier. So I'm going to create a repository, and I'm going to create a file, and we can see that the file repository attribute is set to the name of the repo that we're going to create. So I can type yes, and then we'll create a repo and a file in that repo. So now I'm in my Terraform repo, and if I refresh the page, I can see that I do indeed have a file here, and it has those test contents. In this video, we're going to go over Terraform variables. Now in Terraform, if you have a attribute that normally you want to allow people to provide an input for, you would create a Terraform variable for it instead of hard coding it. So in our example, instead of hard coding the name of the repository, we're going to turn this into a variable so anybody can provide any name they want when they run our Terraform code. So when it comes to Terraform variables, the first place you want to start is go ahead and create a file, and we'll call it variables.tf. And this is where we're going to define our Terraform variables. We define variables in Terraform with a variable block, and we give the variable a name. So this will be repo_name, and this can be any name you want as long as it makes sense. And then within each variable block, we define which type of variable that is. Is it a string type variable? Is it a Boolean type variable? Is it a number type variable? For us, the repo name must be a string, so we'll define type string. And then we want to give the variable a description. What is this variable that we are defining? The repo name of the GitHub repo to be created. And then finally, we want to define a default value, meaning if the user of this Terraform code does not provide a input variable, what variable are we going to use by default? So by default, I'll make this one repo to rule them all. So if users don't provide their own repo name, they'll get this one by default. The next step in creating variables is once you've defined your variable within a variable block, you can go back through your Terraform code and you can place that variable somewhere. So in order to reference a variable and define an attribute as a variable, we need to say var dot and then the name of the variable, in our case repo name. So now when the resource GitHub repository is created, the name will be the variable that we provide for repo name. And if we don't provide one, the default value of our variable will be used. So to demonstrate what happens when we have no default value, I'll comment this out for now. and then I'll go ahead and run a Terraform apply. And you can see that I am being prompted for the repo name of the GitHub repo to be created. So this is the description of the variable that we created. And it's important that your descriptions make sense for this very reason. If someone is prompted for your variable, they should get a clear idea of what they need to provide as the value. And I'll just say test repo, and this will create my repo as my test repo. Now, to demonstrate what happens when we do have a default value defined and we don't define an input variable, I'll uncomment the default value and I'll run a Terraform apply. And now we can see that it's trying to change the name of my repo from test repo to the default value because I didn't provide a variable for the repo name. Now, in order to provide our own input values efficiently without relying on editing the default attributes of all of our variable blocks, we can create what's called an input variables definition file or terraform.tfvars file. So I'll come into my working directory and I'll create a file called terraform.tfvars. And here's where we will put all of our variables and their values, and this will be the variable definition file for our code. So we only have one variable right now, and that's repo name. So we'll just start by defining repo name and the value, and I'll say, let's see, the best repo. And now I have defined the input variable. So I'll do a Terraform apply, and we can see that now the repo name is being replaced from the default value in our variable block to the input value we provided in our terraform.tfvars file. And this becomes useful when we have a lot of variables we need to provide at once. We can simply template our tfvars file, and then if we need to make changes, change the variables from here in one central location. So now let's try this with a different type of variable. So we've got overwrite on create here as an attribute, and the value is true. So let's go ahead and create a new variable, and I'll just copy this variable block, and we'll call it overwrite on create. And this is going to be a bool type variable because it's either true or false. And we will give it a description of, do you want to overwrite the file on creation, true, false. And then by default, we'll go ahead and set it to true. And then we'll come over to our main.tf and we'll say var.override on create. And then we'll come to tfvars when we'll define override on create as true or false. By default, it's true, but we want to make it false. So we'll say false, and we'll do a Terraform apply. And this will update our repository file resource in place and change override on create from true to false. In this video, we're going to learn about the Terraform data source. In order to get information about an object or resource managed outside of this Terraform code, either by other Terraform code or just not managed by Terraform at all, and then take those values and use them in our Terraform code. In order to use data sources, we have to define a data block. And that data block is a resource in Terraform in which we have to tell the data block which Terraform resource are you attempting to read data on. For example, if you're trying to read data on a GitHub repository and get information out of it, then you need to define GitHub repository as the data source. And the name is not the actual name of the GitHub repository. It's simply a unique identifier for this data source. So this could be repo data. Now it's getting a little cluttered in our main.tf. So usually the best way to keep things clean is to take all of your data sources and remove them from all of your files and place them in a central file called data.tf. Now the data.tf file has no special meaning in Terraform. Terraform doesn't even care it exists. It is simply for us to help keep things organized. So similar to resources, if you go to a provider's documentation page and click on the documentation, you will see that we have data sources that we can look at. And we can look for GitHub repository. And this is an example usage and other information on how we would use a particular data source. So according to this documentation, we can use the name of the repository or the full name, which would be the GitHub org/name of the repo. We're going to use name. So in our data block, we're going to define name equals, and then this would be the name of the GitHub repository as it exists. Now I've got another GitHub repository that is not managed in this Terraform code, and it is named Azure Windows VM. So I have access to this with my GitHub token, and it is in my org, so I don't need to provide the full name. I only need to provide name. So here I'm telling Terraform to go out and grab data about a GitHub repository named Azure Windows VM. So what I want to do is I want to create another file, but this time I'm not going to put it in that repo we're creating. I'm going to put it in that repo that already exists outside of my Terraform code. Now, if you look at the documentation for every data source, it tells you this section attributes reference. This is all of the data or all of the attributes from that data source that you can reference in your Terraform code. So you'll notice here, repository name is not one of them, but you'll notice that default branch is one of them. What I'm going to do to make this a little more friendly is we're going to turn this into a variable. So I'm going to create another variable, and we're going to call this existing repo name. And then the description will be the name of an existing repo to add a file to. And we're going to get rid of the default value. So for now, this will be a required variable. We're going to go to our main.tf, and we're going to define this as var.existing repo name. We're going to define existing repo name and the value in our terraform.tf vars. And this is the Azure Windows VM GitHub repository. And then in data.tf, we're also going to reference var.existing repo name. So now we're telling the data source to look out into our GitHub account for a repository named whatever this variable we provide is, which is Azure Windows VM. And then a file will be created. Oh, and the resource name needs to be unique. So we'll call it file2. And the file2 will be created inside of the existing repository. And now we can actually add a branch attribute, but this will be equal to data.github repository .repo_data .default branch, because that is a valid accessible attribute on this data source. So now when I run a Terraform apply, which should happen, we should create another file in an existing repository named Azure Windows VM, and the default branch, whatever it is, will be pulled from the data source. So we can see that the default branch is set to main, which is being pulled from this data source that we defined. So we can hit yes. Apply complete. So let me go check. So now in this Azure Windows VM Git repository, I can see that a new file has just been added just now, test. We have successfully defined a data source to pull data on an existing thing that is not in our Terraform code, not created or managed by our Terraform code. And then we have passed an attribute from that data source into a resource. In this video, we're talking about Terraform output values. And output values make information about our infrastructure or our configurations available so we can expose that information to either view to use somewhere else just for our benefit, or later on in Terraform, we're going to learn about Terraform modules. We can pass outputs from one module as inputs into another module. So in order to use an output value in Terraform, we first have to define an output block, and we have to give that output block a name. So this output name, what we're going to get is the git clone URL, right? So when we create this GitHub repository, we don't know the URL that we want to clone it from yet. So I'll just call this git clone URL. And then in here, we need to pass a value. And that value needs to be a valid attribute that we can reference on a resource that we create. So we're going to create a GitHub repository resource. So that would be GitHub_repository.repo, the repo that we're creating. And then what information do we want to gather about this repository and output, right? And we want the git clone URL. So we're going to, after we create a GitHub repository up here, we're going to then output the git clone URL. So like we did for data sources, it's getting a little crowded in our main.tf. So good practice is let's copy this output to create another file, and we'll call it outputs.tf. And again, just like data.tf, outputs.tf has no special meaning. Terraform does not care what outputs.tf is called. It's just simply a good naming convention that we should abide by when creating Terraform code, so it's clean and standard out. And we'll paste our output in here. Now we're ready to run a Terraform plan. And we can see that now we have changes to outputs. We're going to add one output git clone URL, which will be known after apply, and that will be taken from our GitHub repository.repo repo that gets created, and that will be taken from the git clone URL. So we'll do a Terraform apply. Yes. Repo, and our files have been created, and we can see now that we have an outputs section here, and it says git clone URL equals, and then the actual URL to clone this Git repository. Now, additionally, we can also add a description to our output variable, the clone URL of the GitHub repo, and we can also say sensitive, right? So if whatever output we are outputting is sensitive, right, like a password, we can set this to true. When we run a Terraform apply, we can see that the output will show sensitive. And it's important to note that if we take a look at our state file, terraform.tf state, and we look for outputs, we can still see the value of that sensitive output within the state file. So even though you set a value as sensitive, if someone has access to your Terraform state file, they can still get that value. In this video, we're going to go over sensitive Terraform variables. So sometimes you create a Terraform variable that is a password or a sensitive secret, a token of some kind, and you don't want that sensitive value to show up in your Terraform plan and apply files or logs. So if I run a Terraform apply right now, we are creating a GitHub repository with Terraform, and we can see in our plan here that has been output, we are being told that the GitHub repository name is the best repo, and that is in plain text. So if this were something like a database and we had a password attribute and we defined a variable for the password, that would show up here in our Terraform plan, the value of that password. So to demonstrate how we fix that, for each variable, we can optionally provide a sensitive argument as true or false. So let's set it to true for the GitHub repo name. And then let's go ahead and rerun Terraform plan. And we can see now, if we go up to the GitHub repository resource, the output for the GitHub repo name just says sensitive value. So that protects us in one way by making sure sensitive values do not make it into our Terraform plan and apply outputs. Now that does not prevent the value from appearing in the Terraform State file. So if I run a Terraform apply, and that repo gets created, when I look at my state file and I look at the resource GitHub repository, that name is still there in plain text. So to recap, setting a variable to sensitive in Terraform only ensures that the output of your Terraform plan and apply does not output sensitive data, but it does not protect people from getting the value out of your state file where it still exists in plain text. So Terraform comes with what are called built-in functions, and these are functions that allow us to call within an expression to transform or combine values. There are different functions like numeric functions, string functions, collection functions, and so on that allow us to do different things. We can use a built-in regex function to perform regex, join function to join strings, date time functions to manipulate time and put those in our values. So for our example, we want to append the current date to the end of our repo name that we create. So we'll provide var.repo name dash and then the date. And we'll do that with a Terraform function. And we're going to be using the format date function. So for each function, you can come and look at the documentation and you can see how you might use this function. So we need format date, we need to provide a spec and a timestamp. And back in our code, we need to go ahead and modify name. So we'll start with quotation mark, $, and then a squiggly bracket. And then we will enclose that in a squiggly bracket and then a quotation. Now this syntax here, this $, squiggly bracket, allows for string interpolation, but it also allows for us to use dynamic values and to evaluate expressions. So then what we need to do is we need to do dash, and then we want to go ahead and do $, squiggly bracket, and then the closing squiggly bracket, and then we will call our function format date. And then we need to go ahead and provide the inputs for this function. So we need our spec, which is a string. So we will do 4-letter year dash 2-letter month dash 2-letter day. And we'll do timestamp, and we'll just leave that empty. Go ahead and save that. And now when we run our Terraform plan, we should see the repo name that gets created be a combination of our variable repo name, which, if we remember, comes from our terraform.tf vars file that we provided in an earlier video. So it'll be the best repo, and then dash the current date. So I'll run a Terraform plan, and then go ahead and remove the sensitive value equals true from your variables.tf if you still have that set. So we can go ahead and view the actual name. We'll run a Terraform plan, and let's see if we can get the name. Let's see here. No. And we can see that the name of our repository that we're creating is now known after apply, whereas before it would have been known right now because Terraform has to figure out what that date is to append. So we'll go ahead and run a Terraform apply, and we'll see what the name of our repo is when it gets created. Okay, so our repo has been created. So now if we go ahead and look at the Terraform State file, and we look for our managed GitHub repository resource, and then we go down to full name, we can see that it is the best repo 2023-729. So let's go to GitHub and verify this. And now I have a repo called the best repo 2023-07-29. In this video, we're going to go over the count meta argument within Terraform. So within Terraform, we have the ability to create multiple resources by passing what's called a meta argument into every resource, right? So if we wanted to create 2 GitHub repositories, we could specify count equals 2. If we wanted to create 10, count equals 10, and we would get 10 GitHub repositories with all of these same settings. If we did not use count, the only way we could get multiple GitHub repositories is to create multiple resources. If I wanted 3 repositories, I would have to have 3 unique repository resources, repo 1, repo 2, and repo 3. And that's very inefficient. So to get around that, we can provide the count equals meta argument and then how many. So I want to create 5 GitHub repositories. That means I'm going to get 5 identical repositories with 5 of these identical settings in this resource block, which means they can't all have the same repository name in the same GitHub, or GitHub will not allow that. So how do I get a unique name for each repository without providing one manually? Well, when we provide the count meta argument within a Terraform resource, that makes the count object available to us to evaluate within an expression. So what we could now do is we could say count.index, right? So I'm going to create a repo named whatever my variable repo name is. So if I look at my Terraform TFRs, that is the best repo. And then it's going to be named the best repo dash, and then whatever the index number is. So if you're familiar with what indexes are, indexes start at 0 and they increment up. So if I'm going to get 5 GitHub repositories, I will get the best repo 0-0 through -4. Now, because we are creating 5 GitHub repository repos using the GitHub repository resource, and we also want to create a file in each one, we need to specify count for the GitHub repository file as well. And this number needs to match the amount of GitHub repositories we're creating. So I could simply type 5 here, but now this would get a little bit tedious, right? And we want our code to be as accurate as possible. So what we're gonna do is we're gonna use the length function, right? So going back to Terraform Functions in the last video I created, and then we're gonna provide GitHub repository.repo. So what we're saying here is that we want to create the same amount of GitHub repository files as the amount of GitHub repository.repos that we create, which will equal whatever this is set to up here. And now everywhere in our Terraform code where we reference that GitHub repository.repo, we need to now reference it's an instance on the index. So what we will do here is we'll do GitHub repository.repo square brackets count.index. So for every index, we will for every index, all 5 indexes, we will create a GitHub repository file in that repo. And then there's one other place in our code we are referencing GitHub repository.repo, and that is our outputs. Now we cannot use a count block in an output block. Terraform just will not allow us to do that. So what we will do is we will access every instance within the index for our output. So we will do square brackets and an asterisk, and that will say access every single index. So now if we run a Terraform plan, right, we can see our outputs are outputting 1, 2, 3, 4, 5 outputs, a URL for each repo that gets created. And now you'll see up here in the code, see if I change this to just 0, access index 0, and run a plan, I would only get 1 output. So by doing asterisk, I can ensure I access them all. And we can see we're creating 11 resources. So we're creating, so if we scroll to the top of our plan, we're creating repo 0, 1, 2, 3, and so on. And we're creating repository file 0 in the best repo 0. We're creating repository file 4 in the best repo 4. So let's run a Terraform apply. Yes. So all my repos and files are creating. And now in GitHub, I can see that I do indeed have 5 repos starting at 0 all the way up to 4. Let's click into one. And we can see that we do indeed have our test files in here. Now, some of you who are a little more experienced in the coding industry, have been around for a little bit, you might notice that there are some inherent disadvantages to using count in this way. And one of them, right? So right now I'm creating 5 repositories. Maybe I wanted to delete 2 of them using Terraform. So maybe I only wanted 3, right? Well, I have no way of specifying which ones I want to delete, right? Maybe I wanted to delete index 2 and 4. But when I change this from 5 to 3 and I run a Terraform plan, all Terraform knows is that I don't want 5 repos. I want 3. So what Terraform is going to do is it's going to go out and it's going to destroy from the top of the index down the last 2. So it's going to get rid of repo 4 and repo 3 and then all of the files within them. So I don't have too much control when I use count. And to solve that, we can use the for each operator where we can specify a map of key value pairs. And we'll go over that in another video. So in the last video, we went over how to use count in Terraform to create multiple instances of the same resource. And then we used the count.index to increment the name of each repo so that they would have a unique name. And some of the disadvantages of count were that we were dependent on our index. We couldn't really make unique identifiers, and changing the number of instances would cause other instances to be destroyed, and we couldn't manage resources individually. So Terraform helps us out with another meta argument called for each. And for each allows us to create multiple instances of a resource based on the elements of a map. And this gives us a more granular way to control our resources. So to get started using for each, follow along. Let's define the for each meta argument at the top of our resource. And we will reference a variable. And we'll call our variable GitHub repo. All right, so that means we need to go ahead and create a variable. So if you remember from a previous video, we created a variables.tf file. And at the top here, I'm going to define a new variable. So this will be GitHub repo, because that is what we've defined. And then the type is going to be a type of map. And this specifically will be a map of strings. Because when we define for each, we must pass a map or set variable type. And within our map, we are going to have a default, and then each element of this map is going to correspond to a resource instance that gets created. So we need to look at this resource and pick out the attributes that we want to allow to be passed in by variable. And specifically, we just want name, right? And maybe we'll do visibility too. Yeah, so we'll do name and visibility. So this is a key, and this will be, we'll make this the name of the repository. So I'll call it repo 1, right? And then maybe we want 3 repos. We're going to say 1, 2, 3, repo 2, and repo 3. So this is the key. And then what we can do is we can specify a value. So maybe this will be, is our repository public or private? So maybe we want repo 1 to be public, and then we want repo 2 and 3 to be private. And then we want repo 2 and 3 to be private. All right, so now within our map, we've got 3 key value pairs, 3 elements, 1, 2, 3. So this is the key and this is the value. So now what we want to do is we want to come back over here and we want to access the name on each dot key. within the var GitHub repo variable, which is this variable we just created. So the name of each repo will be the key in the map. And then visibility is the value of each key, right? So what we can do is we can specify each.value. So each repo will pull its visibility from the value of that element. So now, just like we did with count, we want to create a repository file in each repo that gets created. So we'll get rid of count and we'll replace that with for each. And remember, it has to access a variable of type map or set. So we have to access, so we'll go ahead and access our GitHub repo variable. And now for the GitHub repository name that we want to put the file in, right, that is going to be taken from each key. So we can actually replace this with each.key. So now we're saying for each GitHub repo that gets created in this map, repo 1, repo 2, repo 3, go ahead and put a file named test inside each repo. Now for the output, it gets a little more complicated because we cannot specify the for each meta argument in an output block. So what we have to do is we have to create a for expression and then loop through each repository in the var.github repo variable that we create, so our map. So we're just going to go ahead and delete this from the value, and we're going to do a squiggly brackets, and then in here we're going to say for repo name and repo visibility in var.github repo, right? So within our variable of our map variable, colon, the repo name equals greater than the GitHub repository dot repo name dot clone URL. Git clone URL. Oops, I made a typo here. Go ahead and fix that. Should be one var. All right, so now if we run a Terraform plan, we'll see we have 7 to add, and we are going to get 3 outputs. So I'll run a Terraform apply. I can see I have repo 1, 2, and 3, and if I look inside, I have my file. In our last video, we went over how to use the for each meta argument in Terraform. And when we did that, we accessed a map that we created as a variable, and we had a key value pair, so with the name of the repo and then the visibility of the repo. So the name was the key and the visibility was the value. And then we accessed the name attribute as each key and the visibility attribute for our repository as each value. And in that video, we went ahead and we defined a map of strings, which only allowed us to do key value pairs. And that limits us because what if we wanted to define a more complex data structure, right? What if we wanted to define more attributes like name, description, and visibility? Or if we did file, what if we wanted each one of these to be a unique value in our map? Well, to do that, we would change this map variable from a map string to map object. Now, when we do a map object, we need to define what each object within our map is going to look like, the structure of that object. So I'll start with an open parenthesis and then an open squiggly bracket, and then I'll hit enter. And now I need to go through the resource here. So we will do GitHub repository again, and I need to pick each attribute that I would like to define in my map. So I want name, description, and visibility. So I'll say name is going to be equal to a string. Description is going to be equal to a string. And visibility is also going to be equal to a string. So here we're defining what do we want each object in our map to look like. So each repo will be able to define a name, description, and visibility within our map here. So then I'll come back to main, and I'll be able to access my GitHub repo variable, right? So I'll be able to do access each object, each dot value dot, and then the name of the value for in the object, right? And then we're going to do the same for description and visibility. So each dot value dot description, and then each dot value dot visibility. Now, back on our variable GitHub repo, right? The variable that we're accessing using for each. Under default, we're going to define each object, right? So now I'm going to have repo 1, repo 2, repo 3. So we'll start with repo 1. I can get rid of equals public, and I can say equals squiggly brackets, enter. And then we have to define our attributes the way we've defined them up here. So I need name, description, and visibility. So we'll do this. I'll copy and paste. And this was going to be the name of repo 1. So repo 1, name, the description, my favorite repo, and the visibility, and then it'll be public. And then we're just going to do the same for each repo that we want to create. All right, so I've defined my map here, and then I've defined my 3 objects within my map, my 3 repos, and all of the settings that I want them each to have uniquely. So now verifying in main.tf that I've also specified each dot value for the name, description, and visibility. I'll go ahead and run Terraform plan, and we can see that I'm creating 7 resources. So I'm creating repo 1, my favorite repo, repo 2, and repo 3. Now for each file that we are creating, right, we're still saying put each file in the repository named each.key. So if we kept this like this, right, the key would actually be this. This is the key in the map, repo 1, repo 2, repo 3. And so we're not creating a repo named repo 1, repo 2, repo 3. We're creating repos named whatever this attribute here in each object is in our map. So if we kept this the same, we would try to create files in repositories that don't exist and will never exist. So we need to change this to each.value .name. So for each GitHub repo, right, GitHub repo, object in the map, value name, put a file in there. All right, so it's done. My repos are created, my files are created. Now, if I look at my GitHub, I have my 3 repos the way I expect them with their unique names and descriptions and visibilities. In this video, we're talking about conditionally creating resources based on a condition expression. So what if we wanted to create GitHub repositories, but we wanted to give people the ability to create files based on a condition, right? Maybe we create a variable in here in our terraform.tf vars called create file in repo, in which somebody could say, as they use our Terraform code, true or false. And then based on that input, true or false, a file would be created in the repository that gets created. So the way we can do this in Terraform is with what's known as a conditional expression. So here is what that would look like. You would have a condition, a question mark, and then what happens if your condition is true, and what happens if your condition is false. And what we can do in Terraform is for each resource block, we can take advantage of this conditional expression by using count equals and then evaluating our condition and deciding what happens if the condition is true or false. So in this example, we had created an input create file in repo. So real quick, let's go ahead and create this as a variable. So variable create file in repo. It'll be a type equals bool because it evaluates the true or false. The description will be create a file in the repo that gets created, true or false. All right, and then just to be uniform with all of our other variables, we'll give it a default of true. All right, so now what we can do is we can say var.create file in repo, right, for that variable. If it evaluates to true, right, and then what happens when it evaluates to true, and what happens when it evaluates to false. So if it's true, we'll create one count resource, one file in the repo. And if it's false, we will create 0 files in the repo. And then to make this less confusing, I'm going to go ahead and get rid of the file being created in an existing repo from the data source video we went over. And now with our input for create file in repo as false, we can run a Terraform apply, and we should only create a repo. So one resource to add, and that's a repository. We shouldn't create a file based on this condition. And there it says plan 1 to add. So let me cancel that. And now let's change the value to true. So now we want to create the file in a repository. So we'll run a Terraform apply. And now we're creating 2 resources, a repo and a file within the repo. In this video, we're going to talk about Terraform modules. Modules in Terraform are a way for us to write code once, package it up all into a pretty package, and then put it somewhere, such as here, the Terraform public registry, so that other people can then download our module, and instead of writing all the code, all they have to do is provide the inputs for the variables, and they're off to the races. First, we're going to focus on consuming a module before we work on producing our own module. So if you want to use a module, say you wanted to deploy something like an Amazon S3 bucket, or in our case, create a GitHub repository, because that's what we've been working on, you would come here to registry.terraform.io, and you would choose browse modules, and then you could filter by provider, right? And you would click on the module that you want to use. So in our case, because we're doing GitHub repositories, I'm going to search GitHub up here, and then under modules, I'm going to select see all. Now there is this module under here called Mineros-io, right? And this is a Terraform module to manage GitHub repositories. Now when you first come to a module, it doesn't matter which one it is, they're all going to have a source code link here where you can click and you can see the actual source code, the Terraform code that is being used to write this module. So if we open up this module code, we can see, just like we had in our Terraform code, we have a main TF, outputs TF, right, variables.tf, and then we've got a few other things in here that the person who wrote this module put in here. We've got a README, a license, and we've got some examples on how to use this module, right? So they've told us, here's an example of how you might use this module in order to create a public repository. And then if we go back to the module page, right, we can also see that we can click on the examples here to see examples. And this is essentially a copy of the README here. And they've got some sections here on how to use their module. So they've got a getting started section here. So we're actually going to go ahead and copy this, and we're going to start consuming this module. Now, if you've been following along with me, we have been creating our own Terraform files, and we've been creating a GitHub repository and a file inside of that repository as we learn Terraform. So now what we're going to do is, to demonstrate how we would consume a module, is I'm going to go ahead and actually create a new folder here, and I'm going to call this backup. And I'm going to go ahead and I'm going to put everything that's in here into backup, because I want to save it for later. So now we can see that my Terraform working directory, right, is empty. Where I'm at right now, if I run a pwd, I can see that I am in the users Joshua Terraform code folder, and that is where I am here. And then all that contains is .terraform and backup. So no Terraform files in this directory. So what we're going to do is we're going to create a new file, and we're going to call this main.tf. And then we're going to take that example module code that we copied earlier from the Terraform registry, and we're going to paste that in here. And then we also need to go ahead and take the Terraform block and the provider configuration block from our old Terraform code, copy that, and put it into this main.tf. Because even though we're using a module, we still have to specify our provider and our Terraform block configurations. So let's go over the module block real quick. So every module block has a name, a unique name, right? So if I wanted to call this module twice, I would have to call this repository 1, repository 2, right? They would just have to be unique. And that I could create 2 repositories that way. So let's reset that back. So source. Source is where is this module that you want to use coming from? So in our case, we're pulling from the Hashicorp public registry. So this is mineros-io/repository/GitHub. And that's where we're sourcing this from. And then what version of this module would you like to use? And we're saying use 0.18.0, but allow the number, the rightmost number of that version to change. So we could legally, according to this constraint here, do 18.1, 18.2, and so forth, and it would still be valid, but we can't do 19 because we have a operator here preventing us from doing that. And we have whatever options whoever wrote this module will allow us to pass in, right? So the person who wrote this module is allowing us to pass in the name of a GitHub repository. So we're just going to call it Terraform GitHub repository. What license template do you want to use? And what git ignore template would you like to use? And that's it. That's all we need. So you'll notice compared to our last bit of Terraform code, right, which is under this backup folder, we've got all these files. Now we've only got one file. So now I can go ahead and run a Terraform init, and it's going to initialize my backend like it always does, but you can see that it says initializing modules, and that's new because previously when we were running Terraform init, we didn't get this message because we weren't using a module. And you can see it tells you where it's getting the module from, what version it is, and then it does the normal Terraform init stuff that we expect. So now making sure that our GitHub organization token is properly set as an environment variable, let's go ahead and run a Terraform plan. And we can see that we're going to create one repository, and here's all of the settings that will be used. We're going to do a Terraform apply. We'll accept that. And now we're creating our repository. So it's done. So now if we flip on over to GitHub, we can see that Terraform GitHub repository has been, and that it has the license file, which was the Apache license file template that we chose. And we can see that the .git ignore has been configured to ignore important Terraform files, because in our Terraform code here, we specified which git ignore template to use. So we have successfully consumed a public module and filled in the inputs and used it to create something. And we didn't have to write all that Terraform code that we had to write in the previous videos. And then in the next video, I'm going to teach you about creating or producing your own modules, because when we think about Terraform modules, we think about them either as a consumer of modules or a producer of modules. In this video, we are going to create or produce our own Terraform module. So in the last video, we consumed a Terraform module. We took one right here from the Hashicorp public registry. We provided our values, we ran a Terraform apply, and we got a GitHub repository. Easy. And all we needed to do was make this one file, main.tf, define our Terraform configuration block, our provider configuration block, and our module block. So to produce our own module now, I'm going to go ahead and I'm just going to delete all this stuff in here from consuming our module because we don't need it anymore. I'm going to take all that code we've been working on to create our GitHub repository and our GitHub files. I'm I'm going to actually move that back into my Terraform working directory. I'm going to delete my backup folder here. I'll open up main.tf. All right, I'm going to run a Terraform init. All right, now everything is set back to the way it was set before we consume that module. So we're back to just creating a GitHub repository and a GitHub repository file with Terraform. So when it comes to producing your own modules, the first place you want to go is out to developer.hashicorp.com, and you want to check out the section within the Terraform documentation about modules called Module Development. And this has a little guide on how to create modules. It's not going to walk you through it step by step, but it's going to give you some guidelines. So let us say we wanted to create a Terraform module that allowed people to create GitHub repositories and GitHub repository files. How would we go about doing that? Well, we've already done the most important part. We've wrote the code that is the core of our module. So what you do is you write your code, and then within your Terraform working directory, this will be the root of our module. So this is the root of our module. I'm going to go ahead and delete all these erroneous files like terraform.tstate, backup, anything .terraform as well, because we don't want any of these in our module. We don't need them. All right, nobody else consuming this module is going to want those. And we also don't need our terraform.tfvars file. And then what we want to do is we want to create a new file, and we want to include a file called versions.tf in our Terraform code. And this is not a required naming convention, but it is popular to set this. And this is where we're going to take our Terraform block and remove it from our main.tf. And I'm going to put it in my versions.tf. And then I also want to specify the required version of Terraform that I want someone to have in order to run my module, right? So I'll just say, so I'm running Terraform version 1.5. I wrote this module using Terraform 1.5. So I know that it's going to work with Terraform 1.5. So I'm going to set the required version for this module as 1.5. And then we also are using the version 5.0 of the GitHub provider. So we want to set that here. Now, why am I doing this? Well, when you write a module, anybody who consumes your module is going to, if you do not have a required version of Terraform set, use their version of Terraform to run your module. And if your module was developed with special features or attributes that do not exist in their version of Terraform because theirs is too old or too new, then it's going to break and they're going to not like your module. So what you do is you specify the version that they must have in our, so that way somebody who has Terraform version 0.12 is not going to be able to use this module because there are features in this code not supported by their version. And the same goes for the provider versions. And then we can also remove the provider block from our main.tf because the users who consume our module will provide their own provider block with the configurations for their provider. Then within your root of your module, it's not required, but it is recommended that you have a README file with some information on what your module is and what it does. So we'll say module to create GitHub repo and file. So that's our README. And next, it's recommended that we also have a folder for any submodules that we would use within this module, right? Within a module, we can call other modules, and these would be nested or submodules. And we would store them in a folder called modules. Again, not required, but highly recommended. And then we would also create a folder called examples. Again, not required, but recommended. And within this folder, we would have different examples of how to use our code. So I could have different folders in here, like how to make a public repo, and I could have a folder on how to make a private repo. And in there, I would demonstrate, sudo demonstrate, using this code the same way a user might use it. So this is the second video of us creating our own module. In the last one, we left off where we had created our module directory structure. We had just created our examples directory. So we're going to pick up where we left off from there. So at this point, we've written our module. We've got the directory structure all ready to go. So the only other thing we haven't done so far is decided what can people pass into our module. And this is actually going to be every variable that we've created. And we've already done this. So we've got a variable. What's the repository name you want to create? We've got a variable, do you want to overwrite on create? Right? And if we open up variables.tf, we've got existing repo name, which we actually don't need anymore because we're no longer creating a repo in an existing repository. And we've got a variable, do you want to create a file in a repo? And if somebody passes, yes, I would like to create a file in a repo, then we will go ahead and create a file. So these three variables are the only three things that users can pass into our module. And then because we have default values, they also don't have to provide them because they are being provided for them if they provide nothing. Now we want to extend this a little bit, and we want to decide to let people name their file that gets created in the GitHub repository. So I'll create a variable called name of file, and then we'll also allow them to pass in the contents of that file. So we'll say var contents of file. Right, and then obviously we need to create these two variables. So in variables.tf, I'll just go ahead and copy this one. We're creating two variables, and this is file name. That's how we named it. Name of file, sorry. Name of file. And then we've also got contents of file. So contents of file, and this will be the name of the file to create in a repo. And by default, the name will be test file. And then the contents of the file, contents of the file being created if creating a file. And by default, we'll just say these are test contents. All right, so now our users can provide these 5 input variables with our module. Additionally, we have 2 examples here, private repo and public repo. So we'll go ahead and we'll create a variable that allows us to decide if it's private or not. So we'll say var.repo visibility as a variable. And we'll go ahead and create a variable, and we'll call this repo visibility type equals string. So we'll allow them to type private or public. Description, private or public repository setting. And then we will default this to private. So just to make sure that our module works as we expect, let's go ahead and fill in our examples here so that we can test it. So under one of our examples here, I'll create a new file and I'll just call this main.tf. And in here, we're going to call a module block, and we have to give the module a name, and we'll say GitHub repo module, right? And this just needs to be unique for each module that block that we call within our code, right? So this wouldn't work because they're the same, but we could do module 1 and module 2. And the name doesn't really matter. Just make sure that it makes sense. And then we have to, within the module block, define a source attribute. And this is where is the module that you want to use located. So in an earlier video, we sourced the module from the public Hashicorp registry. And that was an example of sourcing a module from a remote location, a remote registry. We can also source modules from a local location, right? Somewhere within here. And we know that the root directory here is the location of our module, right? Our module code is actually right here. So that's one directory, two directories up relative to this main.tf file. So knowing that the module is actually located two directories up from this one, what we can do is we can do .. Say, and that's telling Terraform from this directory, private repo where we run Terraform init, go up one directory, up another directory, up two directories, and then that's where you're going to find the module. So I've gone ahead and filled in the module block with every single variable input that I'm allowing users to pass in when they call my module. And then we're also going to provide a Terraform block, right? So you can just go to the versions.tf in the root of the module and copy that Terraform block and pop it in your main.tf under the examples private repo, and then provide the provider configuration with the owner of your GitHub org, or if you leave it blank, it'll just use the default owner of your GitHub API token. So now if I run a Terraform apply, we can see that we're going to create a repository and a file in that repository. Now type yes, and we're creating the repo. And it's created. Now you might think, why do we need to provide this Terraform block and the provider block when we already provided them in the root of the module in versions.tf? Well, all the root module versions.tf is doing, it is informing us that if anybody tries to use a Terraform version lower than 1.5 or a GitHub provider lower than 5.x, then we're not going to allow them to. So let's test that. So we're saying only allow users to use the GitHub provider version 5.0. So if I come to my main.tf where I'm consuming the module, and I change this to 4.0 here, and I say Terraform apply, I get a message that says the following dependency selections recorded in the log file are inconsistent with the current configuration. Now, in order to change a version of a provider once you've already done a Terraform init, what you need to do is you need to go ahead and run a Terraform init-upgrade. And you can see that it fails because we could not retrieve a list of available versions for provider integrations GitHub. No available releases match the given constraints. If we change this back to 5.0 and then run it again, now it works because we are using the latest 5.33. So now we know that our module works because we have sourced it locally. So the next step in the next video would be to properly set our module up to be uploaded to a public registry, and then we'll consume it from there. Picking up where we left off in the last video, we created our own Terraform module, and then we created an examples directory with a private repo example, and we tested sourcing our module locally using the example. And in this video, now that we have tested sourcing it locally, we're actually going to go over the requirements and the process to upload your module to the Hashicorp public registry. So like most things you can do with Terraform, over at developer.hashicorp.com, there are some documentation on how to do these things. And under the modules section of the documentation, we have a page called publishing modules. And here it gives us the requirements required to actually publish a module. So to start requirements, we must have our module in GitHub in a public registry. Now this only applies to the public Hashicorp registry. If you have a private module registry internal to you or your organization, you can ignore this requirement. But for most of you watching this video, you will be putting it on the public registry. Name. So the module must follow a naming convention of Terraform-provider-name. This means your repository, the GitHub repository, must be named Terraform- the name of the provider, in our case GitHub, and then whatever we want to name it. We need a GitHub repository description when we create our repo, and this will populate the short description of the module in the Hashicorp registry. It should adhere to the standard module structure, and we kind of went over that already. So we should have a root module, a README, license, main TF, variable TF, outputs TF, right? We already went over all this in the last video, but if you're curious, you can go ahead and come to the documentation and you can click on the standard module structure to get more information. And finally, we must create a release and tag it within our GitHub repository. And this release tag must follow semantic versioning. If you're interested in that, you can Google it, but they tell you here it should be either major version, minor version, patch version, or V major version, minor version, patch version. So either 1.0.0 or V 1.0.0, nothing else. So to get started with this process of uploading our own module, go on over to your GitHub org, click repositories, and go to new repository. Go ahead and give it a name, and it must follow that Terraform-provider name, in our case GitHub. Name of the module, whatever you want to name it. So we'll say repo creation, and we'll give it a description. This is required. This will be the description as it shows up in the Hashicorp registry. A test module to create a GitHub repo and file in the repo. Okay, and then it must be public. We have to make it public. We don't need to add a README because we already have one in our module when we created it in the last video and the video before that. A .gitignore, actually we want to search Terraform here, and this will prevent any sensitive files like state files or anything like that from being uploaded here on accident. And then we have not created a license, so we'll go ahead and choose one. And I'll just choose Mozilla Public License 2 for this. And then I'm going to hit Create Repository. So I've created a repository, and we only have a .gitignore and a license file. Now there's two ways to do this. So we can use the git CLI to actually push our files here to this repository. But if you're new to this whole Git thing, DevOps thing, right, you're just kind of new to it, and you don't have the git CLI or you're not comfortable with it, we can do it a second way. So the first option, using Git, we're going to go ahead and actually click the green code button on our repository. And unless you're set up for one of these two, you're most likely going to be using HTTPS. So go ahead and copy this clone link. And then back in our VS Code terminal, I'm going to go ahead and type git clone, and then I'm going to paste that URL. And what that does is it clones that repository into wherever I did the git clone. So here I can see that I now have my GitHub repository here created as a new folder. And then what I'm going to do is I'm going to take my files for my module, all of them, and I'm going to put them inside the repo. I'm going to move them all in there. So now my GitHub repository folder that I cloned contains my Terraform module. And then I'll go into my Terraform GitHub repo creation Git directory, and I'm going to type git add dot. And this is saying add all the all the changes that have occurred in this Git repository, stage them so I can commit them. And the dot specifies for this directory that I'm in. And then I'm going to do git commit -m. So this is saying I'm ready to actually commit all of the changes. And then I have to give it a message. What should people know when they view your commit in GitHub? Adding Terraform module code. And we can see all the files that I put into this repository that weren't there have now been put into create mode. And the final step is to actually push them to our GitHub repo with a git push. All right, so they should be pushed. Now, if you are not comfortable with the git CLI, or you just don't have it installed or you don't want to deal with it, when you create a repo the way I just showed you, you can actually have the option to hit add file, and then you can upload new files, and you can simply go ahead and choose your files or drag and drop them here to add them to your GitHub repository. Okay, so let's take a gander at our GitHub repo. Let's refresh this page. Oh, and look, my module code has been pushed. All right, so step 1, create the repository. Step 2, put your Terraform module code in the repository. 3, we have to create a release with a tag. So we'll hit create new release and we will choose a tag and we'll just start typing and we'll say version 1.0.0 and then we'll hit create new tag v1.0.0. Choose the main branch. It's our only branch. And the release title, initial release. Give it a description. We made this. Whoop. And we will go ahead and publish a release. All right, so now we have a release and we have a tag. So that's the other requirement knocked out. Now all we have to do is publish the module. Now to upload our module to the Hashicorp public registry, we need to come up to the top and somewhere it's going to say publish module. And then once we're signed in, publish module. And now because we're signed in with GitHub, all of our GitHub repositories should show up, assuming we gave them the proper permissions and access when we signed in. So I'm looking for Terraform GitHub repo creation. So that's the one I'm going to choose. I agree to the terms of use. And now, as long as everything meets the requirements that Hashicorp requires of me to upload this, I should be able to hit publish module. And then this should do its thing and we should see, boom, our GitHub module has been uploaded. And we can see any inputs that we're allowed to put in when we consume this module, the outputs that we'll get, how many resources it deploys, and so on. We can see our examples, right? And we have populated private repo with an example.